objectives will be to use radian measures for angles and to find the length of an arc of a circle. Essential understanding: an angle with a full circle rotation measures 2 pi radians. An angle with a semicircle rotation measures pi radians. A central angle of a circle is an angle with a vertex at the center of a circle. An intercepted arc is the portion of the circle with the endpoints on the sides of the central angle and remaining points within the interior of the angle. So the intercepted arc, if we look, would be this part of our circle. A radian is the measure of a central angle that intercepts an arc with the length equal to the radius of a circle. Radians, like degrees, measure the amount of rotation from the initial side to the terminal side. So it's just another way to say the angle measurement. We can use the proportion d over 180 equals r over pi to convert between radians and degrees. But easier way to do so would be to multiply by the fraction. So if we are going from degrees to radians, we multiply by pi over 180. And if we are converting from radians to degrees, we multiply by 180 over pi. The way you can think about this is whatever we want to cancel goes on the bottom. Whatever we want, so whatever unit of measure we want goes on top. What is the degree measure of an angle of negative 3 pi over 4 radians? So we're going to take negative 3 pi over 4, and I'm going to multiply by 180 over pi. My pi's cancel, and in my calculator, I am going to do negative 3 times 180 divided by 4. So negative 3 times 180 divided by 4. I get 135. So this is equal to 135 degrees. What is the radian measure of an angle of 27 degrees? So now I'm going from degrees to radians, so I'm multiplying by pi over 180. And when we're talking about radian measurements, we leave the pi. So I'm going to take 27 divided by 180, and I want the simplest fraction, so I'm going to math, enter, and I get 3/20ths. Therefore, this is equal to 3 pi over 20 radians. What are the exact values of cosine pi over 4 and sine pi over 4? When we are working with trig functions of radians, we do the same thing. We draw our angle. So pi over 4 is in our first quadrant. And I draw my triangle. Pi over 4 is equal to 45 degrees. We are going to have to memorize pi over 4, pi over 3, pi over 6, and pi over 2. So since I'm working with a 45, 45, 90 triangle, I'm working with square root of 2 over 2. So the cosine of pi over 4 is equal to root 2 over 2. Since I'm in the first quadrant, that is positive. Then sine of pi over 4 is equal to root 2 over root 2. For a circle of radius r, an essential angle of measure theta in radians. So our angle measurement needs to be in radians. The length s of the intercepted arc is s is equal to r theta. So if we have this circle at our right, what is the length s to the nearest tenth? So we have the angle s, the central angle as 5 pi over 6 times the the radius, which is 3. So this is equal to s, therefore s is equal to 5 pi over 2. Since it says to the nearest tenth, I will do 5 pi divided by 2, 7.9. Instead of this, you guys are going to tell me, you're going to convert 30 degrees, 60 degrees, 45 degrees, 90 degrees, 180 degrees, 270, and 360 to radians.